right, so in section 5.6, we are going to be graphing linear equations. And this is something different, something new that we have not seen yet this year. So every single thing we've been working with so far has mostly been an equation, meaning that we have an equal sign. So we were graphing equations like y equals 2x plus 1. We were looking at systems of equations, like looking when these two lines intersect. But now we're going to be looking at not linear equations, but they're called linear inequalities. The only way we can solve these types of problems is by graphing. So if you aren't really loving the whole graphing thing, you're going to have to try and, refresh your memory and make sure you understand how to graph in slope-intercept form again, because it's the only method in solving these types of problems. So a linear inequality in a coordinate plane with an x and y axis looks similar to this picture here. So it looks kind of the same as a linear equation in that you have a straight line on the graph, but there's two main differences with inequalities. If you remember in the beginning of the year when we solved just regular inequalities, like x is less than 1. If you remember for those types of problems, we always created a number line and like a type of circle, an open circle or a closed circle, and then we either shade it to the left of the line or to the right of the line. The same type of situation is going to happen now, but because we have two variables, that makes us have an actual coordinate plane graph. And we're going to have a solution region, which is going to be a shaded region, either above the line or below the line, depending on the problem. And that's one difference. We're used to just graphing lines and then just having the line, nothing else. Now we're going to be used to shading some parts of the line in. And also, the lines are not always going to be solid straight lines like you're used to using. Sometimes they're going to be dotted or dashed lines, depending on how the problems ask you about the line. I usually call them dotted lines. So here's the formal notes. You can graph inequalities on coordinate planes. The lines can have positive slopes, negative slopes, zero slopes, or undefined slopes, just like they can with equations. But the main difference here is that we are going to have the shaded region. So it's either going to be above a line or below a line. So this linear inequalities graph is on y is less than 2x. And what's interesting about this is it's similar to the equation y equals 2x. So y equals 2x, the starting point is at 0, 0, since there is no like plus 1 or minus 3 or anything like that. So this is the starting point. And the slope is 2, which is the number in front of x. You go up 2 and over 1 and you make a point there. This line, if I just connected it and didn't shade anything, would be y equals 2x. But what happens with inequalities is that you have to pick a type of line. There's two types of lines. We have these dotted lines, and dotted lines are only for when you have less than or greater than. So right here they're calling it dashed line, same thing. Dotted or dashed lines only occur when the symbol is either less than or greater than, and that's because all of the points on that line are not solutions, so you can't draw a solid line that would show that they are. And then you have to find out which of the half planes would be the shaded region, which would be the solution. So every line cuts a graph completely in half. That's why we call them half planes. And to figure out where the shaded region occurs, you have to test a point to figure it out. So here are the steps to do so. So you have to graph the boundary line, and you graph the line by just graphing like almost as if it's the equation, like y equals 2x. And then you will use either a dashed line or a solid line. Dashed lines always are for either less than or greater than, and solid lines are less than or equal to or greater than or equal to symbols. And then you can use your graphing calculator, but I know a lot of you don't have one, so we'll be primarily testing a point to determine which direction to shade. So let's actually get to an example. So in example 1, we are going to be graphing the inequality y is greater than negative 2x minus 4. So this is what we're going to be graphing. In order to do that, we have to pretend like it's an equation and graph just the equation. So forget the greater than symbol. We're going to graph the equation y equals negative 2x minus 4. going to go to this graph here, and we're going to start at the y-intercept. Where does this graph start at? What's the y-intercept? Molly? Yep, at -4 is where we will start to. Everyone please make a point there at -4 on the y-axis. And then from here, we need to use the slope to get to another point. Now, this graph is not very large. We need some more spots here in order to go down to the right one. Remember, when we have an equation like y equals -2x minus 4, this is your starting point. That's your y-intercept, which we already plotted. And this number here is your slope. That means the slope is -2/1, which means we would actually be going down to the right one. If you ever run out of room, you can also do the opposite of going down to the right. The opposite of down to the right one is up to the left one. So you can also go the other way to get a point on the other side of it. Once you have your 2 points, now you're ready to basically draw your lines. But you have to remember that not all of the lines are going to be straight, solid lines anymore. Whenever the symbol is either less than or greater than, you have to use a dotted line. And that's because the lines represent solutions. And when we have less than or greater than, all of the points on the line are not solutions. Whenever you have less than or equal to or greater than or equal to, you would use a solid regular line that you're used to using. And that's because every point on those lines are solutions. Now, because the symbol is a greater than symbol, that means that none of the points on this actual line are solutions. Anything bigger than the line would be solutions. So what type of line would I need? A dotted or dashed or a solid line? Molly? Yes. So to draw a dotted line, you have a couple options. You can literally just keep drawing all of the points and just call that the line. Or you can just go like this and make dashes like this to make it not a solid line. Either way is fine. It's probably not going to be perfect, especially because this year we don't have rulers to hand out and stuff like that. Just try your best with these problems. Okay. The next new thing with the graphing part of this is figuring out where to shade. Now, we want to shade anything that's bigger than -2x minus 4. So if I was to look at this, I would think anything greater than it, just with the way that the line looks, I would think anything up here is probably the area that I would color in. But to be sure, what you're going to do is test a point. So when you test a point, you're testing a region to make sure that what you're thinking is correct. The easiest point to test is 0, 0. So the easiest point is 0, 0. You can only use a point that's not on the line, though. So you can't choose any point that is on the line. The easiest point to use is 0, 0, but sometimes 0, 0 is on the line, so you can't use that point. The reason why 0, 0 is the easiest point is because if I replace in 0 for y and 0 for x, everything turns to 0. This would say instead of y is greater than, it'll say 0 is greater than. And -2 times 0 is just 0. So that whole thing goes away, and you're just left with 0 is greater than -4. Once you get that, then it's time for you to determine if that's true. Is 0 greater than -4? Yes. This is true, which means that all of the points in this area that 0, 0 is in is a part of the solution region, which then my brain was right in thinking that the area above is the answer. So then you have to shade it in. It doesn't have to be perfect. Here's how I shade it. Just go like this. Just show me which side is the answer. Some of you might enjoy this and want to actually shade nicely as if your pencil was a colored pencil. Some of you might not really care and just scribble like me. Just have to show me somehow that would be the area that is the solution region. Now, inequalities don't have just one answer. They have infinite solutions. That's why we have to graph. That's why we have to shade in a region, because any one of these points in this area would be a solution to the inequality y is greater than -2x minus 4. All right, so let's try the next problem. Flip this over to the next page. So in example 2, we are graphing the inequality y is greater than or equal to 1/4 x minus 3. So in order to graph this, we first need to pretend like it's just an equation. And to graph an equation, we start at the y-intercept, which in this case, the y-intercept is -3. So on the y-axis, I go down 3 and I make a point. Then from here, it's time for me to use my slope to get at least one more point. The slope is the number in front of x. My slope is 1/4. Because my slope is 1/4, it tells you what to do from your starting point. It says go up 1 and over 4. So from here, I go up 1 and over 4. 1, 2, 3, 4, and I make a second point. Once I have my 2 points, then it's time for me to draw my line. But remember, there are 2 lines to choose from at this point. You can either draw a solid line through the points if that line is a part of the solution, or it's a dotted line if the line is not a part of the solution. To determine if it is a part of the solution or not, you look at the symbol. Greater than or equal to has this equal to part. Equal to will make every single point on the line a solution to it, which means anytime you have a less than or equal to or greater than or equal to symbol, you will always have a solid line. So this right here is going to draw a line to the best of your ability, straight through those 2 points, because every single point on that line will be a solution to the inequality. And then it's time for you to shade a region. So when I'm looking at the original inequality, which is y is greater than or equal to 1/4 x minus 3, I see that the inequality is greater than or equal to. When I look at this picture, where would your mind think that the greater two numbers are? Your 2 options would be above the line or below the line. Above. My brain does the same thing. After looking at this line, I'm thinking the numbers that are greater than it has to be above. Most of the time, what you think from the actual symbol will be correct. Sometimes it gets a little tricky. So you always want to test a point. The easiest point to test is 0, 0. What you do is you replace 0 in for x and y, and you will get 0 is greater than or equal to 1/4 times 0 is just 0. So you'll get 0 is greater than or equal to -3. What I did here is I just took, this is a little sloppy, I took the inequality and I replaced a 0 in for y and a 0 in for x. 0 times anything is just 0, almost like cancels out. So you get 0 is greater than or equal to -3. That's true, which means that every single point up here is also true, which means up here is your solution region, just like you probably thought when you thought about where does it look bigger than the line. Well, it looks like to be above the line. The only way to solve linear inequalities is by graphing. So every single problem that we're going to be doing now, we're going to be required to graph, which does bring back, all of the different concepts we learned way back when we started graphing from the very beginning. In example 3, we now have just a quick one that just says y is greater than x. So first step would be to pretend like it's y equals x. Y equals x does not have a number at the end here, which means that the y-intercept is the origin. Since there is no plus number or minus number, you start right there at 0, 0. And your slope, since there's no number in front of x, is 1. So from 0, 0, you go up 1 and over 1. All you need is 2 points to make a line. And usually we would just connect our 2 points and call it a day. But now we have to figure out what type of line to use. The symbol is greater than. Greater than symbols always have what type of line? Dotted. So you have 2 options. You can either just make a bunch more dots by just going up 1 over 1, or you can just make them dashed by just going like this, and instead of drawing a solid line, just make a bunch of dashes. Good? You haven't written anything down yet. After you determine the boundary line, which in this case it was a dotted line, the last thing we have to do is determine which direction to shape. And the symbol is greater than. So when I'm looking at this line and I'm thinking about numbers that are greater than it, sometimes gets a little confusing because, you know, like these numbers over here are getting bigger, but where are the numbers greater than the line? My brain is thinking it's above up here, but we should test a point. In order to test a point, you have to choose any point that's not on the line. 0, 0 is the easiest point to use, but can I use 0, 0 for this equation or inequality? No, because it's on the line. So you have to choose any other point. What I'll do is choose a positive point up here in the region I think that's true. I'm going to choose this point, which is 1, 2. This point is in this region above the line that I think is actually the solution. I'm going to test it just to be sure. So when I test it, I basically take 1 and I replace it in for x, and 2 replace it in for y, and make sure that I get a true statement. So when I do that, I'll get 2 is greater than 1. That is true. So my thinking is correct. The area that would be shaded is everything above the line, because when I tested the point 1, 2, I got a true statement, which means everything up here is a part of the solution. Now, depending on the problem, some, like if you are to do an IXL or you to do like a worksheet, they have it shaded in nice and pretty. Sometimes they don't shade it all. They might just put like a big S to show you the solution is up here. So when we are graphing these, your final answer is the line and the region that is a part of the solution. So just FYI. All right, so flip this over to the next couple of examples. We still have some more to do. So in example 4, we're looking at horizontal and vertical lines. These are actually a little bit easier because for horizontal or vertical lines, you don't have to worry about slopes or anything like that. It's either going to be horizontal or vertical. You just have to remember which one's which. So anytime anything starts with x equals, it's always vertical. Anytime it starts with y equals, it's always horizontal. Now, these obviously aren't going to have x equals or y equals because we're not working with equations anymore. We're working with inequalities. But if we were to graph x is less than or equal to 2, I would pretend like it is x equals 2. X equals 2 is a vertical line. So on the x-axis, you go to 2, and I know it's going to go up and down. So I'm just going to make another point above it just to show that it's a vertical line. Then what you need to do is decide what type of line you would need. Because it's a less than or equal to, that means every point on this line is a solution. So I would just draw a normal solid line like I'm used to doing. So x is less than or equal to 2 would be a vertical line, solid like that. These types of problems, though, you don't really have to test the point because if you're looking at these lines, they're pretty cut and dry. It's pretty easy to see the numbers that are less than that line. Your options are anything to the left of it or anything to the right of it. Where are the x numbers that are less than 2? To the left of it or to the right? Left. Yes. If I'm looking at all of these x numbers, here's 1, 0, -1, -2. Anything that's less than or equal to it would be anything to the left of it. Okay, and now the complete opposite. Now we're looking at y is less than or equal to 2. So now we have to remember anytime it starts with y, it's a horizontal line. So we go to the y-axis and we make a point at 2. To help us remember that it's a horizontal line, I'm just going to make another random point next to it to show that it's going to be horizontal. And again, you choose the type of line that you need. Because this is another less than or equal to, we will have another solid line going through the 2 points, or any points. And then just like the x ones, it's very easy to figure out where the numbers are that are less than or equal to this number. Your options are above the line or below the line. Looking at the y numbers, where are the numbers for y that are less than or equal to 2? Below. So anything below would be down here. You do not need to test points when they start with just x or y because it's very easy to determine where the numbers are that are less than or greater than. It's either above or below or left or right of the line. So why don't you guys try the next two? We have x is greater than or equal to 2 and y is greater than or equal to 2. So try the next two problems. I'll give you a couple minutes. Yeah, no problem. All right, so these are pretty quick. They are basically the same exact thing as the last one. Same type of number, same type of line. The only change is going to be the area that's shaded. So x is greater than or equal to 2. You will go to 2 on the x-axis. I know this is a vertical line. It's going to be a solid vertical line because of the greater than or equal to symbol. But anything greater than or equal to 2 will be where? To the right. So over here to the right, I would shade it in. And then for the next one, y is greater than or equal to 2. You go to the y-axis, make a point at 2. I know this is a horizontal line. It is another solid line because of the greater than or equal to symbol. Where are the numbers greater than or equal to 2? Above. Exactly. So these are very simple. When you get ones that are starting with x or y, it's very quick to do. Okay, but obviously they're going to get a little bit more difficult if the inequalities are ever in a form that's not in slope-intercept form. So if we flip over to this last page here with all of these graphing examples, in example 1, we have an inequality that says x plus y is greater than 5. So in order to graph this, the first thing that we need to do, step 1, is put into slope-intercept form. So it's been a while since we've looked at slope-intercept form. Remember, slope-intercept form is y equals mx plus b if we're looking at an equation form of it. Basically, it just takes the equation or inequality and it needs to be solved for y. So if I take the inequality x plus y is greater than 5, you're essentially just solving for y to put it into slope-intercept form. So to do that, you would subtract both sides by x. You'll be left with y. Anytime that you have a symbol, the symbol just always stays the same. You can add, subtract, whatever. The symbol will stay the same. It's still a greater than symbol. And I'm just going to write the negative x first and then plus 5 second, instead of writing 5 minus x, just so that the slope is first, the y-intercept is second. So once I have it in slope-intercept form, which is kind of like slope-intercept form, I know that there's an inequality symbol, not an equal sign. But now that it's in this form, I can pretend like it's y equals negative x plus 5 to graph. Where would I start on my y-axis? 1? Yep, 5. And then from here, I use my slope to get to another point. The slope is the number in front of x, which is what?
1. Negative 1.
Yes, -1. So because it's a -1, that means I go down and over. So down 1 over 1, down 1 over 1. You only need 2 points to make a line. I know I did 3 just to show you, or I did 2 extra just to show you the movement of down 1 over 1. But now I need to pick what type of line to use. It's a greater than symbol. Greater than or less than symbols means that none of the points on the line are solutions. So what type of line would I need for that? Dotted. Yes. So to do dotted, you can either just keep making these points just to show all of the dots. That's fine. Or you don't even have to do that. You can just have a couple points. You just have like just the original 2. And then instead of drawing a straight line through it, draw like a dashed line through it like that. Just so I can see that the line is not completely solid. If you sometimes make a mistake, you might have to draw a straight line and then like erase some parts of it just so I can see that it's a dashed line. And then the last part is figuring out where to color in the solution. So in my mind, anything greater than this line, I'm thinking it's going to be up here. I would think that this down here is anything less than it. So in order to figure that out, I have to test the point. Now here's where it's going to get interesting. 0, 0 is the easiest point to use, so I like to just always use that if possible. So that means I replace y with 0, and I replace x with 0. And I get 0 is greater than -0 is just 0. 0 plus 5 is 5. And this says here 0 is greater than 5. That's not true. 0 is not greater than 5. 0 is less than 5. So whenever you get a statement and it's not true, that means that this area that you tested the point is not the solution. If this is not the solution, then the solution is the other part, which is up here. So sometimes that will happen, and you will get a false statement, which means the point that you tested, that area that it's in is not the solution, which then would tell you the other area is. So sometimes that does happen, and you just have to understand if you get a false answer, then you have to just realize the other part is the answer then. Okay, so there's 3 examples that I really want you guys to try to do on your own. I want to go over these answers before we leave. We have 11 minutes. So please try example 2, 3, and 4. And then before you leave, I will make sure to put the answers up here so you can see the final graphs. Oh, sorry. So example 2 right underneath. And then is there 2 more after that? And then example 3 and 4. Don't forget that the first thing you have to do for all of these is solve for y. All right, so we are going to go over the answers. So example 2, to graph this inequality, the first thing you're going to do is solve for y. And when you do, you'll get y is less than or equal to negative 2x minus 3. That means you will start at negative 3 down here, and we run out of room, so I'm going to go up 2 to the left one. This is a solid line. And then when I go to shade the region, I'm going to test 0, 0. 0 is less than or equal to negative 3. That is not true. So that means that anything up here is not the solution. The solution would be down here. Anything less than or equal to the line would be below it. For the next one, solving this for y, we have to do two things. We have to first subtract both sides by 2x. We'll get 2y is less than or equal to negative 2x plus 4. And then we'll divide everything by 2. And we get y is less than or equal to negative 1x plus 2. So I will graph my y-intercept at 2. My slope is down 1 over 1. This is another solid line. I can test 0, 0 since it's not on the line, and I get 0 is less than or equal to 2. That is true. That means anything underneath the line is the solution, which is kind of what I thought, since anything less than or equal to that line I would think would be below. And then example 4, we have to do the same thing. We have to do 2 steps. We have to first subtract both sides by 2x. When I subtract by 2x, I'm going to get 3y is greater than negative 2x plus 6. And then to get rid of the 3 in front of the y, I have to divide everything by 3. I'll get my inequality is y is greater write 3. This is a dotted or dashed line since it's just greater than. And anything greater than this line is going to be anything up